Okay, here's something I've been working on for quite a while. It's kind of interesting to me. It's a water battery, not real new, but I thought I'd share some thoughts I've got on it and what's going on. I've got a total of 24 cells. I'm using copper and a zinc screw. When I hook them up in series, I'm getting right around 16 volts, which is pretty darn good. And of course, you can hook as much of this as you want in series. You can get any voltage you want. Right now I've got it hooked up in parallel. As you can see, it's hooked up in parallel. And I've got a little LED down here that's lighting up. Let me turn off my light here and we'll see if you can see the LED. Yeah, there you go. You can see it. And it's been running for a long time now. I'm going to come over here and turn the light back on and go over to the meter, and the meter's reading about 1.79 volts. That really hasn't changed. If I come over here and change the scale, I'm about 1.785 volts. So it's up to now. It's up to 1.79 volts, and there it is. It's a 2.1 volt LED drawing about 25 milliamps. I'm going to take the load off from the LED and show you what the voltage is. Voltage is we'll keep going up. It's over 3 volts for 4 cells, and I have a total of 6 cells in parallel here. So I'm still up to 3.25 volts approximately, maybe a little bit more. I'll go ahead and attach the LED again, and you'll see it light up there. And it's lit up. Turn off the light. Boy, I tell you folks, this is about as close to free energy as I've ever seen. I'll turn this back on. I'm up to 1.8 volts. It pretty much is constant at 1.8 volts. It's a pretty darn good example of free energy here. Now, there's been some talk that there's degregation in the electrodes here, the copper and the zinc, but I've been running this now for over a month, and I've seen no degradation at all in the material itself, and the voltages remain pretty much constant, 15 to 16 volts in series, 3.25 volts in parallel. So this is what I'm doing. What's really interesting here is it's pretty obvious that this could be hooked up in parallel in series in a matrix combination to get any combination of voltage and amperage that you want. Also, each one of these cells, I'd say they're probably about 1 3/4 inch by 1 3/4 inch. They could be considerably smaller, probably 1/8 the size. So this whole unit here, which is providing over 16 volts DC voltage in series, and approximately 3.5 volts, 3 1/4 volts in parallel, could be pretty much anything you want. Again, in the matrix system, you could develop very, very high voltage, very, very high current. And I'm going to work on doing this and see how much I can provide. I'll show you that LED again here. So you can see it's still on, it's still running. And there's pretty much of an equilibrium between the voltage and the current is being produced by these 6 sets of cells and what the unit is using. So interesting. There it is. A total of 24 cells. Again, I'm using copper and zinc, and I've got it hooked up in parallel. And I'll keep you advised as to what's going on. Thank you much.